We've had a lot of interest in fuel controls lately for the T62 turbine engine, and I think today we're going to go over a few things on the different types of fuel controls, and we're going to focus mostly on the T62-32 fuel control, which is used on the RotorWay mostly, and how that comes apart and the right way to do it and some of the procedures that I've developed on how to do it. This is a hydromechanical fuel control, and it's different from the 32 in the fact that it has its own built-in mechanical governor. There's three basic parts to this fuel control. We have a pump assembly, we have a governor control unit, and then we have electronics on here that controls the start fuel and main fuel. This is one of the ones that would probably be used in the Black Hawk helicopter on the APU, and it's probably on a 40-1 engine or a variant thereof. This one here is a newer type, and this is from an LC1 engine, which is with very few of these engines made. It's all electronically controlled, computer operated, and it has a pretty extensive information system. I don't have the control box here to show right at this point, but it still uses the mechanical pump. It uses a servo mechanism and two fuel solenoids, and I actually haven't had one of these apart, so I don't know exactly how this works inside, but it's a fairly new type of fuel control. We go over here. This is another 40 series type of fuel control. This one doesn't have the electronics on the back. It has manual adjustments, and both the start and main fuel would be operated with separate solenoids. It has the pump, has the governor body assembly, and it has a manual cap on the back to adjust the RPM and the acceleration rate. We go to this one. This one came out of an older commercial jetliner. I believe it was a Sabreliner, corporate type jet. This uses the similar type of setup. It's driven, shaft driven, pump assembly, hydromechanical fuel control, and some adjustments here. This one has the acceleration unit on the bottom. And you'll note if we look at most of these, and we go back down to these here, these all have altitude compensation units on them, which were designed to be in airborne applications. This one was probably off of a 100 horsepower rated horsepower engine, and most of these can probably be reconfigured to run on a more powerful engine like on the T62-32. I've actually done that. We go over here to the next one. This is on another popular engine. This is off of a T62 2A1 engine, which is used in the single-place helicopters. 95 horsepower engine. Uses a fuel pump assembly, has a governor body assembly on it, and it has a lever that goes on here that mechanically adjusts the acceleration rate. But these engines all run at 100%. So when the engine starts, it'll run right up to 100%. And there's no idle position set on any of these controls that we've looked at so far here. This one is very similar to that last one. This was from a T62 16A2, which was used on the sky cranes and some of the other helicopters. It's also a 100 horsepower engine. Uses a pump assembly, hydromechanical, it's a mechanical governor assembly in here. And we also have acceleration and RPM adjustment on the end. It's just a different configuration. Has about the same flow rate. These are probably a little bit under capable to try to put on 150, 160 horsepower. They have a lower pressure pump in them, and they probably will not flow adequately when you try to really pull a lot of power. And then we get to this fuel control here, which is the T62-32. This fuel control here was used only, as far as I know, on the T62-32 engines, and it's different in the way that it has a throttle lever, much like a car would have. We still have the pump assembly. There is no mechanical governor assembly inside here. It has an altitude compensator. As far as I know, these were never used in an airborne application. They were used in generator sets. And unlike all the other fuel controls, this has a very special start fuel solenoid, which is a three-way valve that opens to start the engine, and then when it closes off, it gives full enrichment back to the fuel control. And that's pretty much what we're going to look at today. I'm going to pull this one apart in a few minutes, and we'll see how this one actually functions. Okay, just a quickie before we start taking this fuel control apart. This is a torque motor that's bolted onto the T62-32 gearbox. It's magnetically controlled, and it takes a little cable in here, and it comes from the governor assembly. This is similar to the ones that are used. This is a newer digital one, and it provides all the motion control to this unit to run the engine. And it's pretty simple. It's just works the throttle back and forth. It probably makes 100 or so, maybe not that quite many, maybe a couple dozen compensations every second that it's controlling the engine. So it'll sit there and flutter microscopically almost to control that engine RPM. Okay, here we are. We're going to start taking this fuel control apart. There's basically three main pieces. We're going to start by taking the start fuel solenoid off. And right here, there's two ports on this. One takes the fuel in through the main port, and it distributes it out to the start fuel port. And that comes from the governor, well, actually not the governor body, but the fuel control body. And these little bushings actually come right out of here. It's kind of important to use the right tools when you're taking these things apart. Another thing I want to cover too is all these surfaces on here, the mating surfaces and the flow surfaces are all type 3 hard anodized, so you want to be careful not to damage those surfaces with improper tools or improper handling, and cause the O-rings not to seat well either. But now we have the three main pieces all apart here. There's usually an O-ring here, which is there. The O-ring that's here is there. And this gasket is in place because there is a donut O-ring. It's a special O-ring that used to go there. And those are pretty much not findable anywhere. So a gasket like this is acceptable in putting these together. And you see some ports where fuel comes through, and they're all balancing circuits within the control. We get leaks around these pump shafts a lot. It's because the O-rings dry up and they start to break, and then the high pressure fuel starts to leak around the shaft. This port is designed to have a pipe on it and go into a puke can, we call it, where you can actually see the fuel running out. Acceptable leaks around the shaft is probably 2 to 3 drops per minute. That's what the manufacturer and the overhaul manual says on this. Now, this whole shaft assembly comes right out of here like this. And these pumps for all these engines are driven at 4,200 RPM. And this is a seal right here. This is an updated one because it's got a bronze seal on it. The original ones were carbon and they break all the time. On this shaft, and I'll show it, I'm not going to take this one apart, but down inside here there's an O-ring on the shaft that allows that seal to move back and forth, and that's why you have the little flexibility in there. That is there to cover misalignment situations, like when this goes into the engine, this should always move around just a little bit like that, so that there's no stress on that shaft. Next here, we're going to pull the cover off so you can see the actual gears. This is pretty much like an oil pump in a car. These are bronze bushings, and they're precision made to seal against the gears that are in there. And you can see that all there is an O-ring to seal this section of the thing. The drive shaft goes into this gear right here, and it drives the gear this way, and the other one drives that way, and it sucks the fuel in and around, and it generates the pressure, which eventually comes out through this port here into the main fuel control body. The last part I'm going to show you on this is where the filter is inside this pump. Each one of these fuel controls has one of these filters. These are cleanable and replaceable. Very important to have that. This is a 10 micron filter, and to clean it properly, you should probably go in a detergent, water, and an ultrasonic cleaner and clean any particles out of there. This is kind of the final filter that goes into the fuel control. Should have a 25 micron going into the fuel control. So you get these two stages of filtration. Another assembly here that's already been taken apart. You can see down inside the bores, the shaft would come through on the bottom there to drive one of these gears. And this is what these pieces look like. This is the whole heart of the pump assembly here. And there's different size shafts, different size gears, so you have to be careful about which ones of these that you put in which fuel control. I'm going to take one of these apart here, and you can see there's 3 little springs on the bottom here, and that's used very small. These things get lost all the time, and once you lose them, you might as well hang it up, because finding new ones are almost impossible. And this slides right off here. There's no ball bearings or anything like that. It's fuel lubricated. You can see a slot in there. These gears are all ground hard gears. They work together just like an oil pump in a car. And you can see these cutouts here, and you can see some of these other little notches. These things have to go together precisely and line up. And you can see the notches on the other one. That goes together like that. Now these have to go back into the fuel control over here in precisely the right way. Now if you put them in 180 degrees out, the fuel control is not going to work. So you got to be careful about that. And you've only got the spline shaft on one of these. If you look, you can see through there. The spline is in that one. The other shaft is an idle shaft and doesn't drive anything, so it's just a straight tube. And that's pretty much what we're looking at here. These things fit so snug down in the bores that there's probably a 1/2 tenth clearance. And what you have to do is make sure these are actually fitting too tight. So they're probably going to have to be polished on the outside. These springs keep tension against the gear, which keeps the pressure up at 600 psi, the rated output. If the springs aren't there, then the fuel is going to leak around the gears and you're going to have very low fuel pressure. This piece here I'm unscrewing is the overall pressure regulator valve. This is where you set the main fuel pressure to 375 or 365, depending on what you're supposed to have. It's adjusted by just turning that screw in. We're going to take it apart so I can show you what it looks like inside. There's just a little poppet valve in there. And there's a little spring in there that holds it. And there we are. There's not a whole lot. The pressure works against the bottom of that, and it releases it, and it comes out through these little holes on the bottom. Pretty straightforward little valve. And that's basically, I usually set these on the engine running, so I can actually see what's going on. And that just basically screws into the body there. And if we go back over to this unit here, this is where you look at it right here. It's right near the throttle. You can take that cap off and you can manually adjust that. Put a pressure regulator in this port right here. I mean a pressure gauge. And you'll be able to see what the pressure is. This is the acceleration control screw. This has to be removed in the place of removing a throttle shaft, but you can see down in through the hole there. This goes down in there, and it's a metering valve, and it's got an O-ring on it, and this is set to a certain point for each fuel control when you make adjustments. We're going to leave that out of there. These are just pressure ports. They're uncapped. I'll take the caps off, and they're internally connected. This is your main fuel out, fitting right here, so your pressure from your throttle valve over here and flow comes out this valve to the main fuel, and it goes right out through that port. This is all internal. Now this is a main pressure regulator. It maintains constant pressure. This is the most difficult part to get out of the fuel control. I have a tool that goes in here and clamps on some of these, but that doesn't always work. So we end up having to resort to beating it on a block, something soft where it doesn't get destroyed. And these don't always come out easy. Sometimes you have to put them in boiling water and wrap them and put air pressure in and do a whole bunch of things. Now there's a little pin that goes inside here, which is this one, and that works on another part of the Altitude Compensator. And I'll show that in a little bit when we get on to the rest of that. But that's supposed to slide in and up and down freely in there. Now there's another piece down inside here that's got to be taken out. We're trying to wrap that, get that out, and that comes out. But then we're left with the spring and the piece down below. And that requires a special tool to get out. And then what we have here is just that special tool. That goes down inside there, and this gets tightened up, and then that comes out. This one came out very easy. And this is made out of brass, and you got to be very careful not to damage the insides of these pieces, because what happens is you lose the precision and you start getting internal fuel leaks. This is another match set of parts. So you can see this is not a tool that you can go buy or anything. This is something I had to make. And a lot of the tools I have here, which are many, to take these engines apart, are all special made mostly by me, to take these engines apart. And some of them will replicate the original tools and others won't. This goes together. This is down inside. This sits on top like this. And that pin goes up and down there, and it works against that little spot you can see on there, and works that plunger up and down to control the fuel flow. And the only part we haven't gone through yet is on the fuel pump shaft, throttle shaft, which is probably one of the main items that get broken on here. This is the way the shaft originally should be. It's a very small piece. This is made out of sintered iron, I believe, and it's ground to a very, very fine finish, probably 5 microns or less. Very precision piece. The replacements for these are always in match sets. You can't swap one shaft to the other. This is a very close fitting shaft, so you don't get any fuel leaking by. A lot of people make the mistake on trying to take these out just by pushing them out, and you can't do that. This is a retaining screw here that screws in to the body. There's a hole actually through the middle of this that allows the fuel to flow into that shaft area. And that also retains, this actually goes down inside the body here. And you have to put this hole with the threads on it, has to line up with the port down below here. And this screw goes on a Allen wrench, and it's got an O-ring, and it goes way down inside, and it screws into that fitting and retains it in place. This has O-rings on it, and to put this together properly, there's 4 O-rings, one here, 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 and here. You have to lubricate it with like a white grease, something that's pretty slippery. This has to go in fairly quickly because what happens in the grooves inside here, I don't know if you can see them in the video or not, the O-rings end up in those grooves, and it seals the outer part of this assembly. What they do is they expand, and when you try to push it the rest of the way in, you start shearing off little pieces of the O-ring. And I tell you, I've had this happen to me a number of times. You get the thing all together and you go to run it, and somewhere inside the fuel control, a little piece of O-ring gets stuck. You end up taking the whole thing apart to find the little pieces that are actually lodged somewhere where you never expect to find them. So I've developed a kind of a procedure for putting that together, and it's worked pretty good. I use Viton 70 durometer, or I'll use the elastomer silicone O-rings that are a lot more pliable and less tear resistant when you go to put the things in. That screw does not hit, but you can see the hole. There's a hole there, and there's a larger one there. So aligning this up correctly when you put it in is kind of important too. The throttle shaft piece on the top has a groove cut in it for the screw where the throttle arm goes, so that'll only go one way correctly, so the shaft will be lined in the right position normally when you put it in. I've also made another tool that when the O-rings are on there, and to line this thing up, I try to make sure it's lined up as close as you can. I do it first without the O-rings. I look down in there and I actually put my tool in there that fits in there, and I'll take a magic marker and I'll put a mark right on the body and on the edge of that rim there. So when I press this back down in, I can see the tool is progressively larger, so it gets the hole and it'll actually get it centered just perfect. So when this screw goes down inside there, you're not cross-threading it, and it'll hold that piece right in. Works very well. Once you've got that in, the rest of it's pretty easy. You just slide the bottom shaft in with the new O-rings on it, and then your throttle arm, you can see right here on this one that's together, that screw collects the notch right there, and that just goes on. There's a wave washer and a felt lubricating pad and a washer underneath there that kind of holds this all in place with just slight amount of spring tension. I just want to show you, these are all the different shafts that you can end up with on these fuel controls. It's quite a variety. This is used in the 100 horsepower ones, not used on the 32s, but we got a number of different manufacturers and different pump styles, so you end up having to replace the shafts with the correct shafts from the correct manufacturer. They all work about the same, it's just the way they were made from company to company. The next piece we're going to look at is the Altitude Compensator. This is what it looks like here when it's installed on the fuel control body. There's a bellows inside here, that allows for altitude change, and it expands and contracts depending on that. And there's a lever inside there that works up and down with the fuel regulator in here. And we're going to see how that works here right now. Control body. Remember this piece right here with the spring and the levers and so forth. This little piston goes up and down, and it actually works against this intermediate piece, which is actually bolts on pretty much like this. That lever pushes that against the spring tension and works up and down, and we got the bellows. This is pretty much what it looks like out of the unit, and that end right there. So as it expands, it goes up and down based on the altitude you're at. Doesn't play a whole big role in these engines because most of the time you're at 2,000 or 3,000 feet, and it doesn't really change much. There's a silicone gasket that's fiber reinforced here. There's an adjusting screw inside here that goes down with a very small Allen wrench, and this is part of the adjustment. It actually works against the back of this, and you have to be careful about when you're adjusting that because that changes the whole fuel flow in the engine. And if that's off or from another engine, you could have a heck of a time getting it right. And this is the one that I usually tell people to adjust from the top here, which there's no bellows on the other side, but this comes down inside here, and that screw right there, you turn it in, it'll enrich the whole fuel schedule, or you back it off, it'll decrease the fuel flow. And normally the way you can look at that is if you're getting low power and you're pulling on all you can and from the engine, and you're getting only 700 or so 800 degrees temperature, then you probably don't have enough fuel going into the engine. So by increasing this clockwise a little bit at a time, you'll get increased EGT and increased power up to the point of where the engine will max out at around 1160 degrees. You don't want to go any higher than that. I usually tell people to run these engines, 50 or 100 degrees lower if they can. Just save the engine. When I look at this, I look for the bottom of this push thing right here to be between 90 and 100 thousandths is a good starting position below the bottom of that. That doesn't mean that it's going to work or run at that point. That's just a good starting point. One more point I want to make is this is filled with a gas. It's probably nitrogen or some other gas. I don't know, one that'll react to temperature and altitude. You can see it is sealed off, and each one of these is marked with the actual length on it. This one happened to be marked at 933. I don't know if you can see it in the video or not. It's hand inscribed on it. And this is how you tell whether this is correctly calibrated or not. This one was broken off, so the screw threads are missing on it, and we're not going to ever use it again. But I'm going to measure this one now. Okay, this is actually called a Bellows Assembly. This one's marked on the bottom, as I just said, 9.933. You measure this with a vernier caliper, and you measure it from the top to the bottom without collapsing it. And this one was pretty darn close, 938. I mean, there's 934. That's pretty much right there. So I'm within 1,000, so that's fine. A lot of times these will get stretched out or collapse completely, and you have to, when you see that it's not functioning properly, you have to remove it, and you actually have to measure it and look and see what it's at. Because some of these will be 1.1, 1.05, 1.20. Others will be down under 1 inch. So you take that and you measure it, and if it's not what it's supposed to be, then you either have to readjust or you have to assume that there's a problem with this thing. Sometimes these things leak. I don't even know how they're put together. It's kind of a complex little piece. I'd be interested to see how they made those. Okay, the last part we're going to cover is the start fuel solenoid. I'm not going to take this apart because they're just not available for replacement, and every time you take these apart there's a very high risk that it's not going to work again. There's some very small carbon pucks in there that create the seals between these two parts of the valve. And once you start damaging those, or if you take this thing apart incorrectly, it will probably never work right again. And it's pretty simple to take apart. These two screws come off, the magnetic piece will slide off. I don't happen to have another one here that I can dismantle, and there's a piston in there that works electromagnetically. It's just like a solenoid. And when this part is off here, it leaves that valve very vulnerable inside to damage because the piston flops around and it puts stress on the edges of the carbon pucks. So we won't be taking that apart here, and that's probably the last part we're going to cover on dismantling this fuel control. I'll probably do another one later on putting this all together. It'll probably go quicker because I'll have all the parts ready and all cleaned and stuff, and then I'll show how the assembly goes. One thing I wanted to point out on these fuel controls, these parts here that you're looking at on my bench are almost extinct now. You can't buy these anywhere. The manufacturer that made these parts doesn't manufacture them anymore. So luckily for me, my camera guy right here is an expert at CNC machining and reverse engineering, and I want to take a minute here to kind of go over some of the pieces we've already made. We have an original piece here, and I have a piece that he has made right here. It precisely matches all the internal specifications that the original did, and we've made a few exterior changes. The biggest thing you'll know that this piece was cast and then machined. This is a fully CNC machined piece from Billet, 6061. I may go to 7075 at some point. We'll see that the internal passages here, which were capped, we might go to that at some point, but we're brass plugging those areas. And those were always done to get access to the internal ports. There's a lot of internal ports that had to be done on here, and this is quite an accomplishment for anybody, let alone somebody who hasn't had any experience doing this. Here we got a cover that goes on the back. I mean, this is a one-for-one replacement cover. This was cast and machined. This is fully CNC machined, and I've checked all the dimensions and everything, and they're actually perfect. It fits right on to the original. I get the right pieces lined up here. It fits right onto this one, so I could interchange these pieces with the original cast, or I can use them on the part that we've actually made here. And it's a great piece of work. This is a rear cap that has the RPM and the acceleration control mounted on it. This is used on the 40 series engines and on the 2A1 type engines. This is all cast and then it's machined afterwards. This is a fully CNC machined piece right here. One-for-one, perfect copy. Everything 100% match up. We've yet to make the center body, and we're going to do a video on that at some point down the road. But the quality of workmanship here and the preciseness of CNC machining, who wouldn't want one of those all nice anodized on their wonderful new engine? The cap is the piece that goes on here for your fuel filter that goes inside. Again, this might have been CNC machined all the way, but we've done the same thing here and making that part. We're going to get into making the internal pieces for this, probably later this fall and this winter. Once we get all the internal pieces made up, we're going to populate a control, and we're actually going to test it on an engine to verify that it works correctly. And once we've achieved that, then we'll have a complete set of re-engineered fuel control parts, and we'll be able to make replacement parts. Again, I'd like to thank my video guy. He's quite a reverse engineer here, and he's done an excellent job on that. To all my viewers who watch this video, thanks again, and we hope you'll tune in for another interesting series of videos when we go to put this one back together and a lot of other interesting aspects of these turbine engines. Thanks again.